Hello, everyone. Thank you for joining and welcome to the presentation, The New Software Development Lifecycle in the Era of Agentic Coding. I originally presented this talk 1 month ago at the Software Quality Days, and today I would like to share the content of this talk with you. As you know, AI is evolving rapidly, and I don't think anyone can reliably predict where this journey will ultimately lead. So rather than presenting definitive answers, I would like today to offer a perspective to share few thoughts, some ideas, and hopefully spark a discussion about how software engineering, quality assurance, and our software development lifecycle look like in the era of AI and agentic coding. My name is Lilia. I am head of quality assurance at MGM Technology Partners. I am computer scientist, senior software developer, almost over 15 years, most likely in the backend. I am senior quality engineer in the context of scalable test automation for enterprise software. I am also a member of the German testing board, and in ISTQB, I am the glossary chair. In case you would like to connect with me, please follow the QR code. Before starting the original talk of the Software Quality Days, I would like to do two small warm-ups, and let we start with warm-up number 1, and let's talk about quality. So when building software products, and if you aim to be successful, so we need to build quality, right? So we aim to have good quality to be successful, good quality of our software product. Quality is essential. In some cases, people come to me asking, hey, Lilia, we built a software product and we are only missing testing at the end of it. Could you please help us with this? So let me tell you something. A software product does not suddenly become high quality because testing is added at the end. It will not, this is a wrong assumption. Testing is corrective, is correcting an existing product or artifact or piece of software. It is revealing defects within this already built product or software. So quality is not testing. Quality is the degree to which a system satisfies the needs of its stakeholders. And the standard ISO 25010 defines clearly the quality characteristics of a software product. So if we want to build good quality, we have to talk about functional completeness, functional correctness. We have to talk about performance, security. We have to consider modularization, modifiability, testability, fault tolerance in the context of reliability, recoverability. If we want to cover accessibility in the context of inclusivity under interaction capability and so on and so forth. These aspects, this quality characteristic to apply to any software product, regardless is built with AI or without AI. They apply always. And with the last version of the 25010, which was in 2023, so ISO added the safety aspect. So the safety aspect for software products, which means if you have here defects, people die. The safety aspect to consider. And now, so if we define, if we want to have quality, so we need to define quality. If we don't define quality, we cannot engineer quality. And later, if you say, okay, I have already built the software product, now I want to put quality in it, I want to make it accessible, this means for you a lot of rework, refactorings, technical depth. So if you want to have the shift left approach and to be sustainable, you have to think about the quality before starting building the product so that you can build quality. And now if the software product is AI based, so within the product we are using AI or an agentic system within the product, So ISO 25059 extended the ISO 25010 with AI-specific quality aspects. So in the context of AI-based systems, the functional correctness is not absolute, is not 100% functional correctness. Why? Because AI is probabilistic, so you cannot have an absolute correctness. So additionally, we have in the context of AI-based systems, functional adaptability because AI systems learn and adapt from data. We have robustness under the quality characteristic reliability, which means we need a reliable performance of the AI under uncertainty and under interaction capability. And from the end user perspective, there is the user controllability, which means the end user is able to influence or override the AI behavior. And we have transparency, and this is very important. Transparency and explainability also in the context of the EU AI Act, which means I am able to understand the outcome, the decisions taken by AI. And in the context of security, we need the ability to prevent or mitigate the harm through intervention, which is intervenability. So these, if we talk quality, we need to talk about these quality characteristics, and then we need to think about which ones are relevant for our customers, and then we build quality. Now, let me move to the second warm-up, and it's about software engineering. So in March this year, I was speaking about efficient end-to-end test automation at the Swiss Testing Day in Zurich. Professor Bertrand Meyer, University Zurich, also a famous author of many valuable books in the context of software engineering, he talked in his keynote about software verification in the age of artificial intelligence. He shared, among other things, the following slide. So if coding can be handled by AI, then what? Coding is 10 to 20% of software engineering. Software engineering includes requirement engineering, which is very complex. Please do not underestimate. It includes architecture and design, also complex. It includes quality engineering. It includes validation and verification. Verification means, did we build the system right? And validation means, did we build the right system? So we validate the system from the end user perspective, from the customer perspective, and many other things. And Bertrand Meyer considers requirement engineering as one of the most difficult parts of software engineering. One of the most difficult parts of software engineering. And he also categorized software products in 3 categories. So we have critical domains. People die if we have defects. So this is the context of safety. It's category A. We have business software products, for example, in e-government, banking, insurance, and so on, is category B. And then we have category C. He name it casual. For instance, you have vibe coded, a training tool, and no one dies and no business harm if this is not functioning correctly. So you have 3 categories, and most likely, at least in my company, because we do a lot for e-government and insurance, so we focus on having agentic, and also in the context of this presentation today, I will talk about the categories A and B. So we aim to have an agentic software development system covering software products of the categories A and B. Now let's go back to the original talk. And this was the agenda at the Software Quality Days. This was my agenda. It was straightforward. After a short introduction, I will introduce at least my vision in the context of agentic software development lifecycle. We will talk about the challenges around the new lifecycle. And last but not least, and this is now not in the context of today, we had a Q&A session. So let me start with the introduction. So in my company, we introduced agentic coding since almost 2 years in few months. And at scale, I would say since 6 months, almost 1 year at scale. So we have a high number of senior software developer using now agentic coding on daily basis. The development of a 2 weeks sprint backlog is now done within 2 days. The developer are using TDD, test-driven development. At the beginning, the developer complained that they have merge conflicts when more than one developer is working on this backlog. And in one case, one project manager complained that QA is now causing a bottleneck for the delivery. I answered this question by telling the project manager the following. I said, if you introduce agentic coding to your existing software development lifecycle and to your existing process, you create an imbalance. And now it's not the question of blaming the QA being the bottleneck. You have to rethink and redefine your software development lifecycle. So if the development takes 2 days, we can no longer say the QA testing phase is 2 weeks. Make no sense, right? So we have to rethink the new software development lifecycle in the context of agentic coding and agentic software development systems. And the third thing is, in few cases in my company, a single developer works alone on 2 or 3 projects at the same time. And the project scope was previously 20 persons, 20 developer, and now he's working alone on these projects. Why? Because he's using agentic coding. This was my board in my office at MGM Munich North. This was the outcome of a workshop with software developer. And this was basically the motivation that motivated me to think, how should the new software development lifecycle looks like in the context of agentic systems? And so what you see in the middle is my visualization of an agentic software development system having an agent orchestrator, most likely sub-agents, and then an execution layer containing the models. And then you have an MCP layer where you can call the tools. Then you might have also a memory layer and so on. So the idea or the core question is, what does it take? What does it take to build high quality software? What does it take to build high quality software using an agentic software development system? So the input is intent, my intent and my context. I give it to the agentic software development system, and I aim to have working, tested, reviewed code. And ideally, I will conduct a few exploratory testing, and that's it. This is the core question, and we will try to answer this question today. At least I will try to give you a few ideas of my vision around this topic. So to answer the question, I started first thinking, what are typically the main phases when developing software? So these are typically the 7 phases when developing software products. And I defined in each phase what is the input, what is the output, and what kind of tests are basically generated or conducted at each level. So at the end, I came up with 7 phases: business requirements, business specification. We have the system requirements phase. We have technical requirements, technical specification, the component specification, and last but not least, the implementation phase. And when doing the implementation, you don't generate code, you do code review, static analysis, and then you execute all the tests created in the previous levels. Okay. Then when considering these phases, and this is very important, we can easily trace back the generated code to the respective requirement. Traceability here is an integral part if we want to, to build software using an agentic system. I believe traceability is an integral part of the system, of the agentic system. It's not optional. Why? It is important for transparency and explainability also in the context of the EU AI Act. It's also important for auditability, especially for high critical domains. So additionally, when using traceability, we force the AI to achieve a certain degree of determinism. So when emphasizing traceability, we get a certain degree of deterministic output by the AI, which is good for our system, for our agentic system. Then I asked myself, what are the artifacts that contribute to achieve high quality outcome when it comes to software development? And after conducting an analysis, I came out with the following 5 groups or 5 categories. So we have the system landscape and context artifacts containing basically the context diagram, for example, defining my system boundaries, who is interacting with me outside of me. We have the architecture artifacts containing the architecture diagram, the component diagrams, the data flow diagrams. We have interface artifacts containing, for example, the interface definitions, also the API specification, and so on. We have data artifacts. So what data do we store? How is it structured? How is it related? What are the relationships? What are the constraints? And last but not least, we have runtime and deployment artifacts. So I call them the essential artifacts. These essential artifacts, if I have them compactified with high quality, they can contribute to achieve a high quality outcome, a high quality software product. This was my idea. And now I will show you my first basically vision how the software development lifecycle looks like fully AI integrated. So I went meticulously through the 7 phases using AI, using always a new context, defining quality gates, generating the respective test cases at the different levels, using high quality essential artifacts, and going meticulously AI based through all the 7 phases. You might think to have a human in the loop at each quality gate or at the end. When finishing the implementation, you run basically the unit test, and so on. You run all the generated tests previously. And I don't want to go into details to this. I want first to show the vision. So this is just a big picture of for example, the business level. So you see is not, you give the input and it's just generating for you the code. You have to consider many things, to have templates, to consider the naming convention, the business glossa, maybe your business criticals. So what is critical for you? And so on. And also when generating the test cases, to apply the test techniques and so on, so that we aim, so I built the 7 phases very meticulously aiming to achieve high quality of the software product at the end using the essential artifacts. And I ended up in this vision, in this picture. So you see here the Agentic V model, AI based. So we have AI at each level. We have testability at each level as well. And I call it the agentic increment. So an increment is the backlog, what you do previously in 2 weeks. And I think it can be done as just a vision within 2 hours with maximum 1 person in the loop. And I put, this is just my estimation, 30 minutes for the business level, because I consider this level the most critical one. Shit in, shit out. So the business requirements and the business specification, it should be high quality so that we can get high quality output at the end. And it's top down basically. At the end, we end up in the last phase 7, which is the implementation. The implementation will take only 5 minutes because we just generate the code. And then it goes again in the other direction, so bottom up. And we run now the generated test cases. We run the unit test, the integration test, the system test, and so on. And it will take 30 minutes for testing, reporting, and evaluating. And we still have 10 minutes buffer for bug fixing. So it's a vision. So it's an agentic V model, basically agentic software development lifecycle based on V model and only AI, and you have quality gates at each level, basically. And now let's go back to Professor Bertrand Meyer, and he shared in the same conference at Swiss Testing Day the following slide with the title Towards a Process, basically towards a new software development life cycle. And his estimation, and I like his estimation and I agree with him. So much more realistically, the software development lifecycle will be something like specify a little, implement a little, attempt to verify a little, and then correct and loop. And in the context of agentic systems, this is more closer than to the reality. So I ended up in a new version of the software development lifecycle that I would like to share with you. And still 7 phases, but differently. So let me start from the beginning. So phase 1 is the requirements engineering, which is a critical phase where we have requirement agent and consistency agent. The outcome is the requirement baseline. And then we start phase 2, which is architecture and design, where we have a design agent and maybe other agents as well to cover different aspects of quality. And then the outcome is we have then the requirements baseline plus the design baseline plus maybe coding standards. And we enter to phase 3, which is the implementation, where we have code writing agent to write the code. We have also a traceability agent to trace back the code to the requirement. We don't tolerate any orphan code. We have dependency agent and so on. Each completed module immediately triggers phase 4, which is the verification, where we have a test agent, a security agent, performance agent, and much more. So we verify the module within its scope. And if we have findings, we go back to phase 3 to fixing. So we might have here a loop. Once all modules are verified, we verify them then together. So here the verification is single module within the scope now, all modules together at system level. And we might have findings. So we have a diagnosis agent with a root cause analysis and the agent. So the orchestrator might then reclassify the faults. We might go back to phase 1 requirement or phase 2 or phase 3, depending on the finding. Once all is accepted, we trigger phase 5, which is review and independent verification, where we have code review agent and the independent verification agent. Also here we might have findings and we need to conduct root cause analysis, and we might go back to phase 1, 2, or 3. Once all is accepted, we trigger phase 6, which is release deployment, where we have a DevOps agent and we do release packaging. And last but not least, phase 7, which is post-deployment, where we have a monitoring agent so that we can monitor the runtime versus the non-functional requirement baseline. So this is my vision of the agentic software development lifecycle. I try to make very close to the reality. And let's dream or think boldly. So regardless is a V agentic model or A for agentic, so A agentic software development lifecycle. If we say one iteration is within 2 hours and you have only one person in the loop, so we might have 3 iterations plus 1 retro. This is 1 day of work. So 3 iterations and 1 retro where you conduct lessons learned and refactorings. Then if we think more bigger in the context of platforms, you might have different modules and you can have in one iteration, you can have the development in parallel of many modules, and then you conduct a second iteration for integration, and the third iteration will be the retrospective as usual with lessons learned and refactorings. Also, in the context of agentic software development systems, we might also introduce strategies to reduce the fluff generated by AI. Also, in the context of testing, let me give you just a small example. Let's say we have a feature ticket with a new feature, and we coded the feature using Cloud Code, and we did our review. The pull request is ready, and in the scope of this feature, Cloud Code generated for me 100 unit tests. So how can I detect the fluff within the unit test? One approach, possible approach, I don't want to critically talk about the test coverage. I want just to give you one idea, is take the 100 unit tests, run them against the previous version. All test cases that run green have nothing to do with the scope of the feature, you can delete them. Sorry. Why you can delete them? Because I expect you have good test coverage and you don't need more. Otherwise, you have duplicates, maybe you have more, you are covering the same thing. So if they run green in the previous things, and we assume in the previous version you have good test coverage, you don't need them. Secondly, and this is my own belief, basically, maybe you know this guy, maybe not. This is Elmar Jurgens. This is the founder of the company Seku SA. His company has a tool called TeamScale to detect gaps in your test coverage. And I believe strongly that we need his tool as an integral part of agentic software development systems. Why? Because we can see the gaps very clearly in red and in yellow, and we can force the AI to close the gaps, and we can reduce the fluff. Now let's talk about the challenges around agentic software development. And let's start with burning tokens like hell. And please do not take this formula for granted. So this is just a formula to visualize how quickly you might burn tokens. So we have turns per agent call. A single agent call is rarely one LLM call, is a multi-turn loop. So for complex modules, a sub-agent can make over 80 turns, 80 turns before emitting a result. Each turn carries the full accumulated context. So as turns accumulate, the context window grows. For example, for instance, turn number 40 costs significantly more than turn number 1 because the context window is bigger. And then you have replan iterations when we detect bugs. So when we have failed quality checks, we have to restart the work, and each iteration might trigger a full new round of agent calls, tool calls, LLM turns against the same scope. So you might quickly burn hell of tokens, and we have to consider, or we have to have token governance, especially in the future. The token price will raise, and we have always to talk about the actual value creation when burning tokens. Now let's talk about the operational challenges. So if we limit the context window, we force the agent to summarize history and we lose precision. We can have critical security problems like prompt injection and other stuff, and this is very critical and crucial. We might have orchestration problems around the orchestration. For example, task decomposition errors It means goals split incorrectly into subtasks incorrectly. We might have agent B waiting for agent A with no timeout. We might have deadlocks and circular replan loops. We might have scope creep or misclassification of faults. For instance, a design fault is then misclassified as an implementation fault, and we run in the wrong direction and burn tokens like hell. Then, as you know, LLM, we have updates. So LLMs have updates, prompt change or might change, data change, the agent behavior might change. So we need here versioned prompts. We need regression test suites that run against model updates. We need to talk about rollback path if a model upgrade, for example, breaks the agent behavior. We surely need an observability layer for agents. Why? We need to trace back the reasoning chain of the LLMs, and we need transparency and explainability. So we need to log everything, and we will log very quickly tons of data, massive logging volumes. And here we have to think about the retention time and also our backup strategies. Because we have an agentic system, we have to define, and this is very critical, control points and to define threshold-based alarms. For example, how many agent internal loop iterations before the agent is considered stuck? How many replan iterations before an alarm is triggered? What token spend per task triggers a cost alarm maybe? What security finding severity triggers an immediate alert? And all this. So we have to consider all these critical points. And then let's talk about us, and let's start with the software developers. So the software developer work across multiple projects and tasks in parallel. They don't trigger an agent and look at the seal. So they trigger the second task and then the third task, and then they have to switch the context constantly, consistently, and they have attention leakage. They are suffering under cognitive load and decision fatigue. We have here higher mental exhaustion and burnout risk in some cases. This is not all. We have organizational challenges. In the context of the developers, senior developers, additionally to the decision fatigue, a few of them told me it's impossible now when using agentic software development systems and agentic coding to review the code. Impossible. So the code is now a black box, even for the senior software developers. It's impossible. We don't care about the code. And they mentioned that they think that at least 30% of the generated tests by AI are poor, fluff. And me as quality engineer, and because I look a bit skeptical in the context of quality, I would say I would assume that 30% of the tests are good and the rest is fluff. And then they mentioned that they have frequent large scale refactorings when using intensively agentic coding. And they said they are happy to have so much automated tests so that they can conduct these kinds of large scale refactorings. And I guess, and this is my opinion, I guess the large scale frequent refactorings are caused by maybe wrong decisions taken by AI in the context of the architecture. Wrong architecture decisions, and then you have to do large scale refactorings so that you are able to scale your software solution. And then another point is TDD. So the developer are now using test-driven development, and I have no problem with test-driven development, but, and now I bring a big but. So the test cases are generated by AI. This is what they do. And then the AI is generating code against these test cases. So if the AI, the first one, generates fluff test cases, you are implementing fluff for the fluff. And this is the critical but I want to bring. Then for the QA teams, we need at the end of the story, we need necessarily exploratory testing. We need creative QA. We need to test the usability. We need to test from the end user perspective. We need to test, for example, accessibility. We need QA for all these kind of testing the business, validating the system. Nevertheless, we have reduced test activities because testing becomes increasingly automated. So an observation out from different companies, we see job insecurity and risk of downsizing and layoffs. And now let's talk about the juniors, not the junior QA, but the junior software developers. They have limited opportunities to build deep technical understanding. They are prompting rather than engineering. They didn't have the possibility to learn it like us the hard way. And they have reduced hand-ons on problem solving and experience because they use AI, so due to AI generated solutions. And here we need knowledge sharing between the seniors and the juniors to catch up. And now from the manager perspective, they have increased pressure from the customer. The customer aims now, you use agentic coding, wow, so we reduce the prices. We need faster delivery with fewer engineers, with less prices, and I aim to have high quality. So rising expectations by the customers. And another challenge might be a greater dependency on external AI platforms, which is critical, and tooling vendors. In long term, you as organization must have a loss of internal expertise on if you rely heavily on AI, and also you lose organizational resilience. And we have to talk about this. And to answer the question, how much AI would you like to introduce within your company? And let me summarize toward a sustainable process. We need to define maximum token limits. We need to limit the size of the context window and to understand deeply the concept of context windows. If we limit the size of the context window, we must improve our input data the quality of our input data, of our input we give to the AI. It must be compactified with high quality to reduce the AI waste and rework. We need to establish multi-turn and retry governance. We need to define determination criteria for these endless loops. We have to use small language models where sufficient rather than large language models for any task to reduce also the burning tokens and the costs. We need to emphasize caching and reuse mechanisms, to use standardized prompt and response templates. We talked about the observability layer and the log retention periods. Do you want to retain your logs for 2 hours, 2 days, or 2 weeks, or 2 years, depending on your domain? If you are in a critical domain and you need to be auditable, you have to think about how to do this. And then we have continuously to foster knowledge sharing within and across teams. And this is very important for sustainability. And this slide was not part of the conference presentation, but I added because it's important. In my opinion, in the context of agentic development, agentic coding, agentic development requires strong engineering foundations. So if we have one person in the loop in our increment, we have one person in the loop assessing the AI outcome. This person needs at least the foundation level of quality, the foundation level of requirement engineering, and the foundation level of software architecture. This is very important. So these are the core skill set for in the age of agentic coding. So that's it for today. Thank you so much for your attention and see you around. Thank you so much. Bye bye.